Thanks for the intro. Hello everybody, my name is Florian Lehmann and I'm from LMU Munich and I'm going to present the topic how to hold your phone when tapping, a comparative study of performance, precision and errors. This is joint work with Michael Kipp from Augsburg University of Applied Sciences, who is also here in the audience. So this is responsive design as we know it, and it only changes layout. What about interaction methods like buttons, sliders and so on? Shouldn't they change too when the screen size changes? In previous work, it was found that touch performance differs depending on factors like surface orientation and where on the screen the touch occurs. As you can see in the figures, if a person uses a touch display, he is faster with a horizontal display than with a vertical display. So we can say context matters. But what is context for touch interaction on smartphones? Here we think smartphone interaction is influenced a lot by how you hold it. For example, we can distinguish between specific grips. You can hold the smartphone in portrait orientation with one hand and tapping with the thumb. We call this the one-handed thumb grip. You can also hold the phone with one hand and operate it with the index finger of the other hand. Which we call the two-handed index grip. Or you can hold the phone with the two hands in landscape orientation and tap with both thumbs. This is the two-handed thumbs grip. So grip as context is defined by handedness, orientation and the active finger. If we want to update the user interface automatically, depending on the grip, how do we know which grip is currently being used? Other work by Hinckley and colleagues showed that it is possible to detect grip by using self-capacitance touch screen, which can be inbuilt. But if we detect grip, how do we adapt our interface controls? Previous work by Buschek and colleagues created adaptive interfaces which showed that they support reachability. For example, by placing UI elements near the thumb, like in the figure. However, these interfaces did not adjust automatically, but needed to be triggered by the user by tilting or using the gyroscope, where Erdle and colleagues also proposed adaptive interface designs which respect the grip, tilt and body posture. However, they did not have detailed performance measurements of different grips. For example, they did not measure performance or precision or error rate on the different regions on the screen. We know we have automatic grip detection, but we don't have detailed enough information to automatically trigger UI adjustments, for instance, depending on the grip. If we have the detailed performance data, we can move from responsive design to responsive interaction, which means automatically adjusting UI controls depending on context. So what do we mean by detailed performance analysis? We had 4 major research questions here in terms of performance. Is tapping with the one-handed thumb grip less precise? And is tapping with the two-handed index grip more precise? In the two-handed index grip, holding and tapping is separated, which we think allows more precise input. And in terms of performance, does the separation of holding and tapping allow for faster taps? And for the two-handed thumb grip, we hypothesize that the right screen half shows a better performance for right-handed people. To investigate this, we conducted a Fitts law study. Participants had to tap on circular targets on a 5.2-inch smartphone. They were allowed to rest their elbows on the table. First, the participants had to tap on the white circle, then on the blue circle. We made sure to cover the whole screen with targets. We used 2 different target sizes and we arrived at 480 trials per subject. For our study, we chose a within subject design to measure movement time, error rate and touch offsets in 3 different grips: the one-hand thumb grip, the two-handed index and the two-handed thumbs. Touch offsets were measured as the difference between the center of the target and the actual touch point. We had 18 participants, ages ranging from 23 to 31 years, and all were right-handed. We also assessed subjective ratings, for example, how difficult or exhausting a grip was perceived. Performance was calculated as throughput after Sokorev and McKenzie based on movement time. And here are the results of our study. The comparison of throughput across grips was significant for all pairwise comparisons. The two-handed thumb grip is the fastest, followed by the two-handed index grip and the one-handed thumb grip. This rejects the research question 3. The two-handed index grip is not fastest. Instead, the two-handed thumb grip is the fastest. Also, there's no separation of the holding and the tapping hand. You tap with both hands. And we also looked at the performance of different regions of the screen. For example, comparing screen halves for each grip. Here I want to show only the most interesting results of this analysis. For example, for the one-handed thumb grip, the right screen half allows for faster taps than the left half, which may be due to the fact that the thumb can reach the right half easier than the left half. The values you see are average, is the average throughput for the region. The higher the value, the faster. And if you now look at another grip, the two-handed index grip, taps in the bottom right quadrant of the screen are the slowest. This shows that different grips can have very different performance characteristics. For the two-handed thumb grip, we found no significant differences in terms of screen halves. This rejects our research question 4. The screen half of the dominant hand does not allow for faster taps. And but when we are looking at the screen thirds, we found a drop in performance in the center. So two-handed thumb grip is slowest in the middle section. We were also interested in the performance of movement direction, and for this we performed another analysis. Here you can see for the one-hand thumb grip that an upward movement is faster on the right screen half than on the left. For the two-handed index grip, we found a difference between the upward and the downward movement. Upward movements are faster than downward movements on the left and on the right screen half. Looking at diagonal movement, we only found a significant result for the two-handed index grip. Taps are faster from top right to bottom left and the other way around. And now let's look at the precision results. Remember, we used touch offsets as an indicator for precision, the difference between the center of the target and the actual touch point. And here you can see that the one-handed thumb grip is the least precise compared to the both other grips. And again, we can see that how you hold your phone influences precision in a characteristic way. And pairwise comparison shows that worse precision for the one-handed thumb grip. This confirms research question number 1. However, there were no significant results between the other grips. Therefore, research question 2 is rejected. And looking at the precision of the one-handed thumb grip in detail, we can see that taps on the left screen half are more precise than on the right, which is surprising because the performance was actually faster on the other screen half. This shows for UI design that it depends on whether precision or performance is more important when making your design decisions. After performance and precision, we now look at errors. Here we found that the one-hand thumb grip causes more errors than the two-handed index grip. And here we also looked at screen regions. For the two-handed index grip, we found fewer errors in the bottom half of the screen compared to the upper half. The same applies for the left half compared to the right half. And looking at the two-handed thumb grip, taps on the right screen half shows fewer errors than on the left. When we compared screen thirds, the leftmost third shows the highest error rate. And next we will look at the results of the subjective ratings. And we found the one-hand thumb grip to be subjectively the most difficult, the most exhausting, and the least successful. And now you may wonder how to apply these results. For designers, we've created a visual overview containing icons where to place your eye elements the best for performance of movement directions, error rate, and touch offsets. Happy smileys indicate a good area for placement, sad smileys indicate a bad one. For example, for the two-handed index grip, the red rectangle, designers should avoid to place your eye elements in the bottom right quadrant of the screen if they aim for high performance. What general recommendations can we give designers? For high performance applications, the top right quadrant should be preferred for these two grips, so for portrait orientation. In contrast, the center third should be avoided when operating the device in two-handed thumb grip, so for landscape orientation. For safety-sensitive applications, the one-handed thumb grip should not be used at all, on the left, and for the two-handed index grip, the bottom left quadrant should be preferred. For the two-handed two-handed thumb grip, the right screen half should be preferred. If precision is your priority, prefer the top left quadrant for both portrait grips. And if your interface uses motion, usual for controls like sliders, then prefer the upward movement for the two-handed index grip. To show you an example of an interface optimized according to these results, here's a basic pull-out menu. And for the one-handed thumb grip, the top right quadrant and the right screen half should be preferred. For the two-handed index grip, the bottom left and generally the left screen half should be preferred. And for the two-handed thumbs, it is important to focus on the rightmost screen third. To conclude, what we showed is that grips, as well as screen regions, as well as movement directions, belong to the context of the interaction. They influence performance, precision, and error rate. For example, taps are the fastest in two-handed thumb grip. For the one-handed thumb grip, taps are the slowest and least precise. And we also provided a detailed visual overview of all our results. This makes us conclude that static user interfaces cannot be optimal for all grips in the same way. And so we suggest to use the grip as an additional input parameter to make interface adaptive to how you hold your phone, leaning from responsive design to responsive interaction. And in future work, we plan to explore other interaction contexts, for example, the relative position of users to the mobile device and the relationship between body posture or movement and performance. And finally, we plan to apply our methodology to in-air gestures. And thank you. Questions are highly welcome.
Thank you very much, Florian. We have time for questions. Please introduce yourself and your affiliation.
Mohammed from Zaarland University. Great work. I have just a question about the difference within users in the hand sizes and also what device you use. There's a famous paper from Antti Oliverta on Kai 2014 about how far can your thumb reach in a
the
device.
reachability paper with
Yes, exactly.
Okay.
So I see that you didn't include that at all, even in the future work. Did you notice any differences between the users? Because I guess like the two thumb ones would be easier if your hands are smaller.
Yes.
One thumb would be
Okay. So we didn't measure the thumb size, and but our observations have showed that, okay, it was a 5.2-inch device, and it's pretty large for most hands. So you most probably will have problems to reach the upper left corner. But as work by Oertli et al. Has also showed that you perform like a push gesture to the thumb. So
There's a force, you mean?
yeah.
Okay.
So that makes it reachable.
Okay. Thank you.
Hello, Sunjung Kim from Aalto University. Thanks for the talk. And my question is, the same guideline will be held on the non-dominant hand. For example, if one-handed interaction, that is both possible to operate on the dominant hand, on the non-dominant hand. So the same principle, same guideline principle will be held on the non-dominant hand interaction.
Can you repeat it? Sorry.
You recommended some design guidelines for
Yeah.
the handed and for the grip.
Yeah.
And the same guideline will be held on when user is operating on non-dominant hand. For example, a right-handed user is using the pawn on the left hand.
You mean like switching the handedness?
Yes. I mean,
Like I'm right-handed and operating the phone with the left hand.
yes.
Okay, our guidelines may not apply to this case. I think this requires some more investigation. Okay, so all were right-handed and they used the phone with the right hand. I hope this answers the question.
Maybe that could be your future work, probably.
Thank you.
Shotemuraka from Yahoo Japan Research. I'd like to know the result of Fitzroy fitness for the two-handed condition. Fitzroy regression expression result, R squared.
Oh, sorry. You mean the regression and
Yes.
correlation?
Yes.
Okay.
Of Fitzroy result.
We calculated that, but I haven't got it in my mind. So we maybe speak later about it. Okay.
Yes.
Okay, thank you very much. Thanks, Brian, again.